Hello, my name is Marcelo Arispe. You are about to see a review of some of the different volcanic and glacial features studied in the Geology 295 class offered at Northern Virginia Community College. Geology 295, Regional Field Geology of the Northern Rocky Mountains, is taught by Callan Bentley from Northern Virginia Community College and Pete Berquist from Thomas Nelson Community College. For the volcanic features, we'll talk about the columnar joints we saw at our Gallatin Range hike, the geothermal features we saw at Yelow Stone National Park, the Purcell Seal at Grinnell Glacier, and the ringing rocks in Whitehall, Montana. Let's start with the columnar basalts or columnar joints. In our second day of the trip, we headed south of Bozeman to the Highlight Peak Trail, which is a 7.2 miles hike. The Highlight Peak Trail begins in a deep glaciated valley surrounded by high peaks and steep ridges. 45 minutes from the head of the trail, we stopped to take a look at the columnar joints. At first, it just looks like a massive talus, but as you get close, you can actually notice and enjoy the columns. How do these columns form? Well, columnar jointing is the product of lava flows or intrusive dikes or seals. They propagate inwards and divide the rock into prismatic columns. So basically, columnar jointing is a type of fracturing in the rock. In this case, these columns are the product of a lava flow. Let's take a closer look at the columns. First, we notice the polygonal shape, but there is one more visible feature: arrest lines. Arrest lines are perpendicular to the columns. They are formed because of the gradual cooling of the lava. When lava cools down, it reduces its mass. So the closer to the surface, the faster it's going to cool down, forming these little sections. That's why we say the columns are formed inwards, the lava body. Let's talk about the geothermal features. Yellowstone has the largest concentration of geothermal features in the United States. Although we saw a lot of them, we're going to concentrate in the Grand Prismatic Spring and the Faithful Gacier. Grand Prismatic Spring is the largest in the United States and the third largest in the world. The vivid colors of the hot spring are the result of pigmented bacteria in the microbial mat that grows around the edges of the water. The amount of color in the microbial mat depends on the temperature of the water that favors one bacterium over another. Grand Prismatic Spring is 250 by 300 feet and discharges an estimate of 500 gallons of water per minute at a temperature of 147 to 188 Fahrenheit. The Grand Prismatic Spring is located halfway between the upper and lower Gacier Basin. It sits on a bed of rhyolitic rock on the west side of the Yellowstone caldera. The white-gray landscape around the spring is created when hot water dissolves the silica of the rhyolite and carries it to the surface. Then the water flows, cools, and the silica compounds come out of the solution and are deposited as a precipitated called siliceous sinter. It is worth it to take a quick look at the Mammoth Hot Spring and mention that the travertine, as opposed of siliceous sinter, can be created by the same process, with the only difference that instead of rhyolite, we have a rock composed of crystal calcium carbonate. Now we're going to see the Old Faithful Gacier. There are two types of geysers: fountain geysers that erupt from pools of water and cone geysers that erupt from cones of siliceous sinter. In this case, the siliceous sinter can be also called geyserite. Old Faithful is a cone geyser located in the upper Gacier Basin. The eruptions can shed 3,700 to 8,400 gallons of water at a height of 106 to 185 feet. The intervals between eruptions range from 45 to 125 minutes, and the eruptions last from 1 to 5 minutes. Purcell Seal. A seal is a horizontal tabletop-shaped tubular intrusion. A war example of this kind of intrusion is the Purcell Seal, which is located in the Grinnell Glacier at Gacier Natioanal Park. The diorite seal cuts the limestone of the Helena Formation from the belt supergroup. Above and below the seal, we can observe a lighter color banding. These are not igneous nor sedimentary rocks. These are metamorphosed rocks. When the magma intruded the limestone, it baked the limestone of the contact zone, creating marble. Ringing rocks. The last volcanic feature we'll present is the Ringing Rocks, which is a mountain summit in the Jefferson County in the state of Montana. The summit has an elevation of 5,682 feet. Why is it a volcanic feature? Because it is an exposed pluton. Why is it called Ringing Rocks? The answer is very simple. This rock is a gabbro and was formed as a pluton due to the laramide orogeny during the late Cretaceous. It is also associated with the boulder batholith of the southwest Montana. It's believed that this boulder batholith is composed from 7 to 14 plutons. Why these rocks have a resonance is a mystery. I hope you enjoyed the volcanic features I presented. Being in the field and experiencing all this firsthand was amazing for me.